Hello, everyone, and welcome to the Canadian Electricity Association's Conversation Series webinars. The Canadian Electricity Association is the voice of the electricity industry in Canada. My name is Alex Kent, Manager in the Regulatory Affairs and Grid Infrastructure team at CEA, and I am pleased to be your host today. The Conversation Series features presentations from CEA's corporate partners and highlights a variety of Canadian and international solutions to current and future challenges faced by the industry. Working with CEA's corporate partners, these webinars have been developed to be of specific interest to those working in the electric utility space from generation on through to the customer. For a list of upcoming sessions, please check out CEA's website at www.electricity.ca. These webinars allow a broad national audience to participate at no or low cost without the need to travel or invest a lot of time. We are broadcasting to you today from Ottawa to over 31 locations across Canada. Before we get started, there are a few housekeeping items. Our session is scheduled to run from 1 p.m. to 2 p.m. Eastern Time sharp. Questions can be asked at any time, and we encourage you to do so as they come to mind by typing them into the chat function on your screen. They will be asked at the end of the presentation. Please set all your devices to mute. A brief survey will be sent to webinar participants following the session today, and we very much appreciate your candid feedback and are interested in any topics you would like to have included in future conversation series. Please keep an eye out for future webinars and events through CEA's monthly newsletter, Current Affairs. With over 6,000 subscribers, Current Affairs is the place to go for Canadian industry news as we connect the national value chain from generation on through to the customer. If you'd like to receive Current Affairs, you can subscribe to this free publication via CEA's website, again, www.electricity.ca. Today's topic is fleet electrification, moving past pilot implementations. And the presenting corporate partner is Burns & McDonnell in partnership with OPG. This webinar will help utility leadership understand the considerations an industrial customer must undertake when planning to transition their vehicle fleet to electric. Their assessments must focus on technology, engagement with the electrical utility, duty cycle analysis, green and backup power assessment, facility modifications, operational and maintenance changes, change management for personnel, cost estimation, capital budgeting, and phased implementation. For example, a transit agency looking to electrify their entire bus fleet, or a logistics company looking to electrify their entire short-haul trucking fleet, or a port looking to electrify all their cargo handling equipment on site. Today's presenters are Travis Bauslag, a manager of strategy and innovation at Burns & McDonnell, Keegan Tully, a senior manager at OPG Generation, and Kyle Pinn, director of EV infrastructure at Burns & McDonnell. Over to you, Keegan.
Thank you, Alex. So just before we get started, I just wanted to give a quick overview of Ontario Power Generation. So we're Ontario's largest electricity generator and with one of the most diverse portfolios of generation assets in North America. And we have assets across Ontario, as well as a large number of assets focused on the northeastern United States. More recently, we've been investing in innovative technologies that will drive clean economic renewal, transportation electrification, small modular reactors, energy storage, microgrids, and even medical isotopes. Over to Travis to talk a little bit more about Burns & McDonnell.
Thanks, Keegan. Just want to give a quick introduction to Burns & McDonnell. So we are an employee-owned organization headquartered in Kansas City, Missouri. We have more than 7,600 professionals spread across 55 offices globally. Most of our team and work we do is based in North and Central America, but we do have an extensive international resume. It's driven by customers that have asked us to expand our services to their overseas assets. I'd say as an organization, we're best known for our work in the power industry, serving clients across the entire energy supply chain. But we also have large practices that serve other key industries and markets, including aviation, oil, gas, chemicals, data centers, food and consumer products, manufacturing, and commercial facilities, to name a few. Within the power industry, we provide solutions to power generation, which includes renewables, power delivery, energy storage, which can be scaled and distributed or backup, microgrids and clean or electric transportation. I'd say our experiences serving customers on both sides of the electric meter have proven to be very valuable, especially within the fleet electrification context, as we help bridge that gap between fleet owners and energy providers. Just real briefly on 1898 & Co., it's a division within Burns & Mac. We provide advisory technology and cybersecurity solutions across the market verticals that Burns & McDonnell serves. And so we work closely with our colleagues within Burns & Mac to enabling us to provide value to our customers across the entirety of their asset life cycles. Moving onto our discussion today, one of the first things that a colleague of mine likes to highlight is that fleet electrification is a journey. And this is really a decade-plus journey that will rely heavily on people to guide it. And the people that likely start this journey aren't going to be the ones that likely finish it. And utilities themselves certainly have an opportunity to be an influential partner or participant along this journey. I think it's well understood that utilities certainly have a role in this transition, regardless if they would like to or not. And that role can really be proactive or it can be reactive. The levers the utility can pull or choose to pull will certainly depend upon the regulatory environment you operate in, the type of utility you are, and really how proactive you want to be. Our discussion today is really going to dive into and highlight challenges or opportunities, depending on your perspective, associated with transitioning to and scaling an electric fleet. And so you'll hear some recommendations from Keegan and Kyle as a means to improve that customer experience. For fleet owners, this journey usually starts with a goal or objective, identified out into the future. They want to decarbonize. And really to achieve said goal, a fleet owner must go through these three phases here. So first, they must evaluate and not only evaluate their options, which in itself is no trivial task, but also decide and commit. Enough of those real and perceived barriers must be moved out of the way in order for them to get comfortable enough with taking that first step. Second, they must implement the transition while maintaining reliable service. So at their core, their goods are people movers. That's their mission. And their ability to do that is threatened by some of the operational complexities or limitations introduced by electric vehicles today. And then third, they must operate the electrified assets and infrastructure successfully to realize that goal. And getting to this point is not trivial. And you have to get through those first two stage gates. And a lot of times just taking that first step toward a scaled electrified future is huge and sometimes requires some constant or consistent nudging. To provide some perspective for the discussion, we thought it'd be good to present the results from a recent publicly available case study. And this case study is based on a public transit agency that has over 350 vehicles in service across a couple of depots. And they operate a mixed fleet today with both CNG and battery electric buses. And at a high level, this transit operator wanted to evaluate the techno-economic feasibility of transitioning a fleet to 100% zero emissions. And they really wanted to know what a phased deployment looked like from a capital, infrastructure, and operational perspective. And like many of these projects, we have found that they're also interested in evaluating on or off-site green power options or alternatives to fuel that electrified fleet. And so I'll just cover some high points here. This transit operator had both single and double deck buses. So, considering and evaluating multiple OEMs is important, as they'd like to have a diversity of suppliers, especially considering some of the wide range of operational performance from these early generation vehicles. From a charging perspective, we recommended 325 kilowatt overhead chargers with dual port pantographs for charging the buses within the depot. This arrangement proved to be the lowest cost option that can meet the needs of the fleet. Most akin depot charging to lower powered charging, but high powered charging may be needed just because of operational limitations is something we've seen. From an operational perspective, 60% of the single deck blocks were feasible and less than 50% of the double deck blocks were feasible to electrify. And what this is really saying is that the electric vehicles do not always meet the operational needs the fleet owner today, and without either returning to the depot to recharge or having access to en route opportunity charging. So in this scenario, a transit operator could, add more buses, modify their operations, install on-route opportunity charging, or any combination thereof. And so technology limitations, or at least limitations today, will be a hurdle that utilities may need to help guide their customers over. I suspect in 5 or 10 years they may not exist, but for those fleet owners that want to start today and have a portion of their fleet electrified by 2030 or 2035, they need to start today recognizing that technology may not fully align with their operational model or needs. The facilities themselves, had a peak demand at the depots that went, from less than 0.5 megawatt to 14 and 8 megawatts respectively. And, we've identified some of the infrastructure costs associated with the charging infrastructure at each depot. Obviously, utility make-ready programs and infrastructure support go a long way to reduce the cost of a vehicle electrification. But, the investment in the infrastructure and the vehicles themselves is significant, which really puts downward pressure on the business case from a fleet owner perspective. Another aspect is most fleet owners want to consider that are considering vehicle electrification want to fuel that with 100% renewable power. We found that they've always wanted to evaluate on-site renewables and/or energy storage, regardless of the technical or economic feasibility. Most of these depots are space constrained. In this particular example, they could supply 5% of their needs with on-site solar, but the rest would need to come from utility or off-site contracts, from a third party. And in this particular analysis, storage was not deemed financially feasible, but projected to be so in the future. And then the last thing I'd like to highlight, just the infrastructure costs for this transition were pretty significant. So 120 million over a 10-year period, with escalation. Biggest drivers are obviously the infrastructure costs themselves, and then more importantly, just the incremental cost for the zero emission buses. Our analysis, our base case didn't necessarily consider stepwise reductions in cost for the vehicles, but in various sensitivity analysis, we evaluated alternate scenarios that included, costs in the vehicles, incentives, rebates, which help decrease that gap. Some of the softer qualitative benefits are harder to quantify or represent monetarily, and in this particular instance, they were not considered. And really, what I would like people to take away from this is, this is a specific example, but the key takeaway is that the business case isn't always a slam dunk today, and that electric isn't the only option out there. So, means that make electric vehicles and the associated infrastructure more economical and easier to implement are very important things to consider. From a fleet owner operator perspective, they're introducing, a new vehicle technology that is disrupting their entire value chain, which creates uncertainty. And I think that's what makes scaling an electric fleet so challenging, because you're impacting more than just the vehicle itself. And really just using the supply chain as an example, you have a new vehicle technology that's still, an early generation technology that doesn't always meet customer needs today, and it may not in the future. If a fleet owner can't navigate that uncertainty today, it's going to really be challenging for them to get comfortable with all the hardware, infrastructure, software, and new fuel provider to move forward. You also just have new fueling technology that's also early generation technology that has relatively limited operational history and quite honestly short useful lives today, which is especially true for some of those higher powered chargers. There's a multitude of software solutions aimed at fleet energy management, charge management, energy optimization, DER integration. And each of these providers continues to expand or enhance their offering, which in some instances creates some complexity for the fleet owners. They look to understand that solution landscape. Additionally, they have to manage both these new solutions with the existing ones they have to maintain their fleet during this transition period. They have a new fuel provider, the electric utility, that has a much different pricing structure than what they know today, that creates some uncertainty in an area where they traditionally had a lot of certainty. And then rate structures themselves aren't necessarily simplistic, but you're seeing utilities introduce more simplistic models to help with this. Finally, they've never owned, operated, or maintained these types of assets, so they may not possess the capabilities, understand the costs, and there's not necessarily a strong network today of O&M providers that they can rely on, or their teams aren't trained or certified to maintain these assets. So all that says is that there's a lot of uncertainty as fleet owners are looking for trusted advisors to help guide them on this journey to electrify or decarbonize. And then just moving beyond the supply chain, I think it's important just to highlight the fleet electrification itself is a complex ecosystem to navigate for fleet owners and, quite frankly, for all stakeholders involved. First, there's just a multitude of stakeholders that are impacted by and engaged in this transition to battery electric, and most are at varying points on their journey. Each have different levels of industry knowledge, and each are viewing this from a different perspective, and sometimes those align and other times they do not. Next, you have very different customer needs. So depending on the service they provide, whether it's moving people or goods, right? A transit agency needs look much different than that of a last mile delivery or, a distributed electric utility fleet. And the support or guidance that a fleet owner needs from key stakeholders differs depending on whether they're local, regional, or nationwide. Interoperability is another challenging subject, one where we see stakeholders commonly talk past one another. It's an area where the industry is making great strides, but as electric vehicles proliferate, I think you'll see some more headaches there, especially as we start to rely on more connectivity and smart charging and optimization. The next item is I think is challenging is securing this operational technology and understanding the impacts associated with downtime for these mission critical assets because of security related issues, just because they're not top of mind. I think it's really easy to look at grid outages, right? It's easy to understand, but in reality, the grid itself is pretty reliable. And as we continue to move and rely more and more on smart, optimized charging, I think connectivity and or security related issues will become a more important issue for stakeholders, just like it is for utilities today. And then the last thing I'll hit on is that, the upfront capital investment and market and business model evolution are quite often interconnected. And it's very capital intensive as we just demonstrated the transition of fleet and deploy the necessary infrastructure to support the operations. And for many fleet owner operators, it's challenging to justify that incremental cost of vehicles, let alone the cost of the infrastructure needed. So hence a great opportunity for utilities and other third-party providers. And then second, you're really seeing some business model evolution and innovation looking to address those upfront capital needs. And so that as a service model, whether it be charging or infrastructure as a service, are commonly discussed in the industry today, which could significantly influence the transition to a scaled and electrified fleets. I think that's something you're going to hear more from Keegan and Kyle. And with that, I'll turn it over to Keegan, who'll present his thoughts on how to address some of these complexities.
Thanks, Travis. And really, it's a good segue. I think a lot of the issues and gaps that Travis has identified, we've really noticed as well, and we've made an effort to try and step in and fill some of those gaps. We've got a number of electrification projects going on at OPG, and we've learned a lot of lessons that I hope to share today with everybody on the line. So one of our major projects is the IV charging network. That's a joint venture with Hydro One, where we're building out Ontario's largest electric vehicle fast charging network. So it's 160 DC fast chargers spread across around 70 locations within the province of Ontario. So connecting to, a multitude of utilities across the province, and have learned quite a bit about electrification via that. Another major initiative for us is a ferry electrification project or two. We're electrifying the Wolfe Island and Amherst Island ferries in Eastern Ontario. So maybe not what you would think of as a typical fleet electrification project, but from our perspective, it looks quite similar. We're really looking at the scope from grid connection, battery storage, right up to the vehicle charger, which in this case is a ferry, and in other cases it's a little bit different. And finally, another major initiative for us is working with TTC to electrify their bus fleet. That's the Toronto Transit Commission. So that's one of the largest bus fleets in North America, and TTCs seeking to electrify their full fleet by 2040. And again, OPG looking at the charging infrastructure, similar scope of work here. So I think we really identified similar challenges to what Travis went through in his portion of the presentation. Bus electrification or fleet electrification requires costly and complex high-power charging infrastructure, and transit agencies and other fleets are used to buying diesel and are usually small commercial customers, and this is all brand new to them. So what OPG is offering is really turnkey electrification for transit facilities, from design, feasibility of electrification right through to construction, operation, and maintenance of the facility, and we'll also invest. We really think this is a good model for working with fleets and transit, because it really allows them to focus on their core operation, integrating this new technology of vehicle into their fleet, while allowing us to focus on what we know best, the electrical infrastructure, and really delivering that, cost effectively and reliably and safely as utilities are, used to doing. So when we start working with a potential customer, we look at capital structure and how this is going to be funded. As Travis alluded to, it's an expensive undertaking. So we're willing to coordinate funding. There's quite a bit of funding available in Canada right now for electrification. We'll also finance or co-invest in infrastructure directly. We'll also do project development work, feasibility studies. A lot of transit and other fleets don't even know where to start. And so we work with them to do feasibility studies to really, assess what it will take to electrify their facilities. And the next sort of phase is really doing EPC, engineer, procurement, and construction on the facilities, and project managing that construction. That's where we fit in. We like to stay with projects right through operations, doing maintenance and operations. We recognize as a utility ourselves that transit agencies are looking for extremely reliable service, and so we're willing to provide uptime guarantees. And finally, we know electricity, and this is a new fuel that transit agencies aren't really used to working with, and so we're willing to help manage electricity costs, whether it's the commodity or other aspects. Next slide. So the typical project structure that we look at is, has a role for many different parties. The local utility is a key aspect of the project. Often you're taking what is a small commercial load, less than 500 kilowatt peak demand, and increasing that load up over 10 megawatts. And so there's a major role for the local utility to upgrade their system, upgrade their feeders, supplying that customer. Where OPG tends to fit in is right from the customer-owned substation down to the EV charger, and we often we believe that there's often going to be a need for battery storage, backup generation, and as Travis alluded to as well, many transit agencies are interested in solar PV. And then that leaves the fleet operator to really focus on their buses or other vehicles, and they have a lot to take on with this new technology, and they can really focus on what their core business is, and we can focus on managing the electrical infrastructure. I think one thing for there's probably mostly utilities on the call is that this is a tremendous opportunity for all of us. Electric vehicles and electrification are one of the biggest new sources of load to come upon us since air conditioning. So I think that has a lot of benefits. So financial value, it's an opportunity to grow rate base, find new sources of demand, and take market share from fossil fuel companies. So that's a great opportunity for us and for us to get behind electrification. You know, we also are very supportive of load growth. I think in Ontario specifically, load has fallen a lot and costs have gone up as a result. You know, the system's heavily weighed by fixed costs, and so you know, as demand for electricity has fallen, you're spreading all those fixed costs over a smaller and smaller amount of electricity, and rates inevitably go up. And so we think electrification is a great way to increase demand for our product while benefiting our customers by, you know, spreading out those fixed costs in the system. And finally, you know, in Ontario and much of Canada, electricity is extremely clean. It's one of the lowest emitting major sectors in the province of Ontario, and transportation is the highest emitting sector in Ontario. So it's really a great story for utilities to tell that, you know, we can clean up other sectors and contribute to, you know, a cleaner economy in the future. Through working, you know, as a utility ourselves and working with local utilities on our electrification projects, I think there's a lot of ways that utilities can help with electrification. We've seen some, you know, interesting work by utilities on special EV rate structures. They're quite different from other loads, and they tend to be very peaky and you know, not solid base load. So there really is an opportunity to work with regulators to develop new rate structures that benefit EV charging. Loads often peak focused off peak for electrification, so it can really complement the demand curve well and focus you know, demand for electricity off peak. So you know, helping other ratepayers, and so utilities can work with their regulators to provide special EV rate structures that help incentivize people to go electric. And finally, another, you know, thought that I had for utilities is around being flexible. Excuse me. There are, in Ontario, there are many local distribution companies, and it seems like policies and you know, rate structures are applied differently across the board. And so where utilities have that discretion, I think being flexible and working with people that are looking to electrify can be really beneficial. Ultimately, this is good for utilities, and so we should be doing what we can to increase flexibility and get behind these initiatives. With that, I think Kyle's up next.
All right, thanks, Keegan. So I'll probably spend just a couple of minutes here, you know, painting a little bit further picture of kind of the difference in perspective that that Travis and I have. So Travis is a thought leader on and often works on the front end of these projects, developing the concepts and working very early to set the stage for electrification projects, where my team is more engaged with the engineering and construction. And so we get to see the customer at a different stage of the journey. And we're working on projects all across North America. And that's actually encouraging to me, because you would think that a lot of projects would be based in areas where there's heavy policy drivers like California, but actually we're finding that electrification is happening all across the continent. And we work very closely with our offices in Toronto and Calgary as they engineer and construct projects to help clients decarbonize and electrify their fleets. And I think that what I'm going to talk about here on this slide is a roadmap that we've developed to help our customers in this journey, because it's a very new way of thinking for them. And so helping them understand. And I think what I really want to point out here that's important for, I imagine, a lot of the audience is the key in the lower left side of the slide, indicating where we believe utilities can influence decisions along this path, and where you can interact with the customer. And so starting off at the beginning is just a preliminary business case. It's using the data that you have and trying to understand, what the economics look like, and setting a baseline. And I think that then gets refined to the rest of the process. Next is an operational assessment, really looking at what the needs are of the fleet. In the case of a transit organization, understanding how many vehicles they have, what routes they need to service, and getting all of that mapped. Then we would do a technology evaluation, and a lot of that is quite frankly because many of the products in the market are still very nascent. And it's important to understand what products are commercially viable and what products are going to meet the needs of the customer. And then I'll talk a little bit later about planning for the future as those technologies continue to develop. The next piece is the energy requirements, and that's really doing a solid mapping of the energy model to understand what is going to be required. And there's so many variables in that. It's easy to take the kind of the color glossy data from the vehicle OEMs and say, I'm going to, this big vehicle is going to consume, 2.5 kilowatt hours per mile or something to that effect. And, you realize that oftentimes that data doesn't line up very well with the real world application when you've got varying, topologies. You've got weather conditions that can be dramatically different, and that's especially impactful in Canada, where you've got a lot of cold weather environments, and preconditioning is required for a lot of vehicles. If not, you use a lot of battery capacity just getting them to a state where it's comfortable for the occupants. Charging needs, really understanding like when are they available to charge, how will they charge, where will they charge. Then looking at the facility upgrades, that's a really important piece because maintenance facilities and operational facilities have been built around many decades of internal combustion engines, and how to maintain those vehicles and store those vehicles, and transitioning that to an electric fleet has to be well thought out. And it's great if your customer has the ability to build new structures. Oftentimes they're retrofitting very, very old facilities to manage these vehicles. Looking at on-site and backup power, that's important from the standpoint, Travis talked about this as well, is that many of these agencies and fleet operators have needs that go well beyond just what their normal operations are, and they rely very heavily on having those vehicles in service, both for normal operations and sometimes for emergency operations. And so it's critically important for them to have a plan in the event that there's a grid outage. How do they maintain their service levels during that event? Utility interconnection is very important, and it I'm going to talk about this a little bit further in the presentation, but there are a lot of things that are underestimated in that process by the fleet owners. Then we take all that information, we reconcile the business case, and lastly, we develop a phasing plan, because most of the time, a fleet isn't going out and transitioning everything all at once. They're doing this, in pieces over a long period of time. So making sure that they've got a cash flow plan and a spatial plan for their facilities to understand how they're going to roll out this infrastructure in a sensible way and maintain operations the whole time that they're constructing. Travis, if you want to go to the next slide. Perfect. I think during the evaluation phase, here are some of the things I think as utilities you can really help with. Share information. I think it's critically important to communicate early and often. I understand that sometimes the information can be sensitive to certain customers, work with them and find out what can be shared. And oftentimes, as a utility, you have some leverage to say, if we're providing power, then we're going to own that data. And I think that there's some leverage that you have there, and then be able to share that with other customers, because that really propels the market when there's data out there to show what can be done. Explain tariff options and limitations. I think rate structures and reimbursement, quite frankly, they can be confusing enough if you work in the utility industry, but then if you're a fleet manager and you have all kinds of concerns, and one of them typically has not been fuel, because you have somebody in procurement that negotiates a year-long contract where your fuel costs are X amount per gallon, and exactly what that's going to be, and it's essentially a fixed cost. Looking at rate structures and demand charges and all of the things associated with that, and just even reimbursement for infrastructure investment can be really, really confusing and complex. And I think it takes a lot of patience to work through that and explain not only how that works, but then how the fleet owners can manage their operations to take advantage of some of those, and how that can end up actually being a very symbiotic relationship. It can help the fleet owner, but can also help the utility. And explaining all of that in very patient ways can be critically important. Grid impacts and costs. I think that the 2-meter costs are oftentimes very, very underestimated, and oftentimes fleet owners don't understand that there's, when they, for instance, they've done a pilot and they had 5 or 10 vehicles and no distribution upgrades were required. Now they're talking about expanding to 100 vehicles or 150 or 200 or more. And now, they need distribution upgrades, and those costs have to be accounted for someplace, and understanding how that works. And transit is an interesting case study from the standpoint that their load is very well known. What the routes are, what the energy consumption is going to be, and once you have their vehicle procurement schedule, you can model that very carefully. There are many fleet owners who their utilization is variable, and so as a utility, getting a handle on what your actual load is going to be is sometimes a little bit tricky. And what that does is it causes most utilities to say, look, you need to front the cost for these distribution modifications, and then we'll reimburse you, over time as you show the utilization. And that's a very, very different concept for the fleet operators. So again, careful, communication and explanation is incredibly important. Drive policy, rate filings, look to make ready programs, make it easier for future programs, as much as possible. I think that the policy can be as big of a blockade to this as anything else. Next slide. Phase your grid upgrades. That's kind of self-evident from a utility standpoint. I think it's important to work with the fleet owners. I think there's sometimes it can be predicted. You can go talk to your transit agencies in your territory and then get a good understanding of where they currently store their vehicles. Same with a lot of fleet operators. You kind of know where they currently fuel. But then I think it's important to work with them also to understand what could be done moving forward, because how they fuel now may not be how they fuel tomorrow. And it's going to be important to know where to put your resources based on where they're planning on fueling their vehicles. Guide charging infrastructure, conversations regarding technology. I think that, these can have a large impact on the control of the load. And also there's a lot of confusion with fleet operators as to, what equipment should I be using? What EVSE should I be using? What software package should I be, using to control this load? And I will point to Southern California Edison. They have a fairly robust vetting system for different charger manufacturers, and they essentially have an approved list. And if you're going to participate in one of their programs, you need to purchase, chargers from that approved list. And I think that offers that peace of mind to the customer that these pieces of equipment have already been vetted by the utility and are going to work in the system well. And then participate in construction. I think it's important to have some voice in that. And I think one really good example of that is King County Metro, large transit agency in Seattle. Seattle City Light is their utility provider, and they've taken one of their senior engineers and embedded them in a key project so that they can be influencing some design decisions and construction decisions along the way. And I think that's an incredibly useful tool, is just to have that communication and to be able to shape some of those things and look at flexibility for the future. Understanding that technologies are changing fast and that the solutions that we have today are many times, they were solutions to problems from yesterday, and so we're still in the process of developing tomorrow's technologies, and that's going to change the way that we implement that infrastructure. Go ahead to the next slide, and this will kind of wrap us up here. I think it's also important to be able to monitor and report on electricity consumption. I think that as these fleet owners begin this journey, they maybe they get a handle on what the new fueling paradigm is going to look like for them, but being able to kind of periodically give them updates on how they're doing is important. A lot of utilities in the U.S. either have or are in the process of evaluating demand charge holidays, allowing the fleet owners to kind of get their feet under them with electrification before implementing demand charges. And I think that can be a very important part of pulling away some of those barricades to electrification. Look at infrastructure as a service. I think that there are many unregulated utilities in the United States that are either implementing programs to offer electrification as a service or at least considering it. And I think that where the regulatory bodies allow, I think it's something that should be considered, because there are a lot of fleet owners who they want to be able to create the fueling as a fixed cost, and it's important for their operations to be able to do that. And they might even be willing to pay a little bit more. It's the whole lease versus buy conversation. Do they want to become experts in electrification and spend a lot of capital up front, or do they want to have that taken care of for them and pay on a monthly or yearly basis for that service? Develop demand response programs, control when charging is going to happen, understand their resiliency needs, looking at oftentimes multiple circuits will take care of an issue, but then sometimes it's on-site storage, and sometimes it requires generation on site to be able to provide their needs. A good example of that is Foothill Transit in the Los Angeles market. We were starting a project with them, and it was actually a surprise to my team to find out that they had an agreement with FEMA, the Federal Emergency Response Association, to be able to provide buses during a natural disaster. And so they needed to be able to provide buses to transport, citizens from one city to another in the event of, say, an earthquake. And that becomes very complicated with an electrified fleet. So understanding resiliency and what the actual, service needs are for those fleet customers is important. And then I think as much as possible, providing clean energy as a fuel, looking to decarbonize your fuel sources. And I know many of you are already well on that journey. And so that's the end of my slides. And with that, I'm going to turn it back over to Alex.
Thank you, Travis, Keegan, and Kyle. So we do have 2 questions in from the audience, and I encourage everyone else to put in. The first question comes from Francis, and this goes to an earlier slide, specifically the electrification of the TTC fleet. How big is that potential? If 100 buses is approximately 20 megawatts, is Toronto looking to build another nuclear unit?
Yeah, so I think it's huge potential, maybe not quite as big as you're thinking. So TTC has 8 garages. If you put it, at 10 megawatts per garage, that's another 80 megawatts, which is quite substantial. And I think OPG would love to build a new SMR to supply that, but I think that can largely be accommodated within the existing system in the near term. But I think that's sort of where OPG is coming from with this is, increasing load via electrification creates those opportunities to build new generation in the future.
Thank you. Next question is from David. If a utility is interested in exploring this this topic more, who do they talk to? OPG or Burns McDonnell? Yes.
I think both. We both obviously have expertise. OPG would work with people like Burns and McDonnell to deploy an electrification project, but we are certainly happy to work with other utilities on it.
Okay.
And I'll kind of add into that a little bit. I think that Keegan's exactly right, and I think the reason for that is that and Keegan, correct me if I say something wrong here. It's not like we're in the same room. You can't reach out and smack me, but virtually smack me. But I think that that utilities have a certain perspective on electrification, and there has been a development over time of the relationship between utilities and their customers, and kind of traditionally utilities have generally had a relationship with a meter and not with the customer. And I think that electrification is providing a new opportunity for utilities to deepen that relationship with their customers. But one thing that has certainly presented a challenge, and some utilities are better equipped to handle this than others, which is understanding each of those unique business cases for those fleet operators. Because what's incredibly important is for each fleet operator to understand that the people that are helping them understand what wakes them up at 3 o'clock in the morning and what their specific operational needs are. And I think that's oftentimes where a company like Burns & McDonnell can help, is we end up providing that additional service, that additional layer, that translation from the commercial customers that we work with to the utility customers that we work with, and being able to translate from that transit language to the utility language, or from that fleet operator language to the utility language. And so oftentimes we end up being that person in between that helps facilitate that communication.
Okay, thank you. Next question comes in from Jason. Is OPG considering offering their fleet program to other fleet organizations other than transit operators?
Yeah, absolutely. I think, we talk a lot about transit just because they're some of the early movers in the space. But, I think, as you can see by our portfolio of projects, we have a ferry project that's not necessarily bus electrification. So we're definitely happy to talk to private fleets or others where it makes sense. I think we're definitely interested in all electrification.
Okay. I remind everyone, please feel free to submit some questions. Oh, here we go. Got another one. What unique challenges does the Canadian environment, hot summers, cold winters, ice, present when electrifying a fleet? I believe you touched on this just a little bit, talking about interior heating the cap, major battery drain. But please, over to you.
Yeah, no problem. I think that what we've definitely noticed is that a lot of the early pilot programs, especially in transit, were in warm weather environments, and the batteries definitely perform better in warm environments. We found out that like air conditioning, for instance, has a lower draw than heating, and so there's actually multiple of the bus manufacturers that provide kind of auxiliary heater units that can be installed in the buses. And this seems a little bit counterintuitive, but they're actually like diesel auxiliary units where a very, very small amount of diesel can be used to heat, and that conserves a vast amount of the battery for the drivetrain. But organizations like New York City Transit, for instance, have large indoor facilities where they bring the buses up to 50 or 55 degrees, so that they're virtually comfortable at the very beginning, so they're not consuming a lot of battery energy to bring the cabin up to temperature. And so I think that there's a lot of strategies that can be used to mitigate that, but for sure, cold weather environments cause the batteries to work harder, no doubt.
I would just add it, I think there's almost advantages. So, in Canada in the winter, a diesel bus needs to sit and idle to get to the temperature, as Kyle was referring to, and that doesn't make neighbors too happy. But an electric bus that's plugged in, can precondition the cabin quietly and be there, and that's another sort of benefit to the technology. But I think utilities can play a role. Transit agencies are an essential service, and they need to plan for the worst. And so that worst day when you're operating in Canada in a blizzard and your range is much lower, you need to be planning for that type of scenario.
I just jump in. One last item is that in Europe, there's been this similar consideration, and so I think you've seen them, transit operators, maybe other types of fleets, deploy the auxiliary heaters, so they're not, as Kyle alluded to, consuming, the battery for their auxiliary needs. And it's been somewhat successful, right? You're only using it for a handful of days throughout the year. I kind of akin it to when you're considering backup power options on site for this, the mission critical assets, and they only want to consider, either on-site green, generation, so solar, or energy storage, when in reality, in these early stages, maybe a natural gas genset is the most economical solution to get them over that concern of not having the ability to recharge their fleet in the event of a grid outage. So, because nothing is more economical than those types of solutions, right? Today. So.
Oh, thank you. I've got a question from Asan, and I'm gonna actually take it and go a little bit further. So his question is, you made a reference to the problem of yesterday's technology versus solutions of tomorrow. So looking ahead, what do you see as promising developments in increasing equivalency of EVs with what people are used to with ICE vehicles? So I think I can push this question just a little bit further over to the Burns McDonnell folk. How do you help clients time their investment? Every year or every month, we get a new EV investment, a new storage announcement. Like, we're getting told that the bottom is constantly falling out of the price of solar. Like, it always seems like if I just wait one more month, it'll always be better. So how do you help your clients time their investments?
Yes, sir. I can start that one. I mean, obviously, what it comes down to is there's a lot of the techno-economic analysis and feasibility of whatever solution we're considering and guiding them on. There's always going to be those early generation hiccups and hurdles that you have to overcome. And so, obviously, as someone that's advising customers on big capital deployments, supporting infrastructure build-outs, right? We're evaluating the risks associated with those, and the potential benefits, and kind of mapping that out and storyboarding that out for them, so that when they transition or pilot it, and then move into like a scaled deployment, we've kind of considered all of those things, so that we've mitigated the risk of a stranded asset or an asset with some hurdles. And I mean, and part of that in this space is you're going to run into those, and I think it's being comfortable, knowing that you're going to have hiccups, and so building in pivot points or off ramps for when they realize that this maybe wasn't the best decision, or we could do it a little bit differently today, that they have the ability to be nimble and pivot.
If I might,
the only thing I would add. Go ahead, Keegan.
You go, Kyle.
I was going to say, the only thing I would add to that is from a very practical standpoint, in our construction, when we're looking at future proofing, a couple of things that come to mind here are, when we're doing underground construction, the vast majority of the cost is actually in opening that trench. So once those trenches are open, installing additional conduit is such a small incremental cost to the overall project that you should never miss an opportunity to drop more conduit in a trench when you can plan it out and say, like, look, I know that there's going to be future infrastructure here, but I just honestly don't know, exactly what it's going to look like. The same thing applies in some of our like really densely urban settings where it's overhead. We can build rack structures that allow for future expansion and kind of building it while you're there rather than having to go back and think about it afterwards. And that really can impact the financial models that Travis was talking about.
I was just going to say as well, if you think about a fleet, it's probably got assets of different ages, and so there's almost a natural step change, because you're not going to just get rid of assets that have useful life yet, and so that can slow you down. It's not like you're replacing every asset at the same time.
Good point. We have time for one last question. We are 5 to the hour, so this one comes from Dane. What can emergency vehicles with variable loads at variable times, such as fire trucks and ambulances, learn from fleet electrification in your work?
I take a stab at it. That's a great
go ahead.
question.
Go ahead,
for it, Kyle.
Travis, please, yeah.
No, Kyle, go ahead.
Yeah, I was going to say that I think the biggest thing is emergency vehicles. I think it's an interesting use case, and I think that we're going to see some more of it. I think there's been some reluctance to head down the path of emergency vehicles just because the perceived reliability of the vehicles maybe wasn't there. But I think that's changing, and I think that when you really look at emergency vehicles, they're often their routes are very short for self-evident reasons. You want quick response times. So they're actually a very, very good use case for EVs. And I think one of the things that we also found out is we ran a project for the U.S. Department of Defense looking at forward operating bases and trying to create a situation where they were more, diesel fuel autonomous or energy self-sufficient, in those forward operating bases for some obvious reasons that, like moving, diesel, during wartime is a really hard thing to do. And I think that what that really pointed out is there's quite a bit of benefits to being able to generate electricity and use electricity, in those, emergency situations. And I think that there's quite a bit that can be applied to fire trucks, ambulances, first responder vehicles.
The one comment I'd add to that is just that, right, I mean, just like anything, you need to evaluate the risks associated with it. So, having I'll say a non-diverse fleet, right, may not be in the best interest, at least during the transition period. So there may be other fueling technologies. I mean, hydrogen comes to mind that may eventually prove to be a better application for these types of situations. But as Kyle alluded to, right, there's a lot of telematics data out there that can really show you and paint the picture of, how does my vehicle actually operate, how many miles a day, and when do I need it, and some of those uptime requirements you have, I would imagine will influence the type and the speed and power of the charging that you need in the event that you're concerned about being able to dispatch, come back, charge, and then dispatch again. So
Great response. Thank you. So that brings us to close. I'd like to thank again Travis, Keegan, Kyle, and each of you in the audience for joining us today. Check out the CEA website. Again, that's www.electricity.ca for upcoming webinars in the conversation series. And if you haven't registered yet, you can do so at our website. 2 upcoming webinars are on November 17th, Fleet Management for Intelligent Electronic Devices, presented by Eaton, and on November 19th, Cloud Security, a new breed of tools and skill set, presented by Longview Systems. This concludes today's conversation series webinar. We'll talk to you next time. Bye for now.